Okay, welcome everyone to Tuesday, Rainy Tuesday. Yesterday I had gone through the examples for lesson 2 and we went through a few questions. And assignment 2, again, it's a really long assignment. I don't think I'll do every question, but I thought that like I'm making this into work period, kind of like I did a couple of days ago. Remember when I let you work a little bit, kind of 5 minutes at a time. So I thought maybe, excuse me, we could try that again. Excuse me. And see how that worked. So let's just take a look at a couple of questions from page 9. So page 9, assignment 2, probability unit. Let's start number 4. The Brandon Wheat Kings hockey team won 7 of their last games. State the experimental probability that they will win their next game. Okay, well, what actually happened? Well, what actually happened is they won 7 out of 10. So that's it. That's as simple as that. Probability can be expressed as a fraction, decimal, or percent. But if they give you however they give you the information, that's how I usually respond. They gave me the number of games won, the number of games in total. I'm just going to leave it like that. Let's take a look at number 5. There are 3 factories in Ontario that produce cars. One year, Factory A produced 5,000 cars, Factory B 4,000, Factory C 7,000. If one car was selected at random, determine the probability it came from plant A. All right. So the probability it came from plant A would be, okay, well, what do we need here? We need the number of cars in plant A. Remember this is the definition of probability. So the top number would have to be the number of cars from plant A. And the bottom number would be the total number of cars. Total number of cars. All right, so the number from plant A, that's easy. It was stated in the question, 5,000. So let's see, I guess that's something they didn't give us this time. So that's that one extra piece of work that we have to do on our own. Factory A was 5,000. Factory B was 4,000. And Factory C was 7. So that gives us 16,000 in total. Probability comes from plant C, so probability plant C, this will be a little easier because I already have my total. Plant C has more cars, so there's a higher probability. Came from plant A or B. Well, that word or, interesting. A or B means it could be from obviously either plant, so I have to include the number from both. So probability plant A or B equals, okay, so the top number has to be both A and B. So 5,000 plus 4,000 is 9,000 out of 16,000. Okay. And plant A or B, this means we add or means we add up the number of cars in A and B. Did not come from plant A. Okay, did not come from plant A. Well, that's the complement of this number, right? This would mean came from B or C. And in probability, the word or means I have to add B and C up together. So 4 and 7 would be, so the probability came from B or C would be 7 plus 4 is 11, 11,000 out of 16,000. Okay. Let's take a look at number 6, and then I'm going to give you a bit of time probability of getting a certain infection is 2% if you're not in the hospital, but 35% if you are in the hospital. That's because the hospital has more infectious diseases and germs and viruses. I think I'm going to have to resort to some paper to do this one because I don't have enough room on my worksheet. So number 6A, probability of not getting so I'm going to write this down. Probability of not infection, not hospital. All right, let's see. The probability of getting an infection is 2% if you're not in the hospital. So the probability of not getting the infection if you're not in the hospital must be 98%. That would be 100% minus 2% equals 98%. So this was the 2% was infection, not hospital. And we wanted the complement of this, the not infection, not hospital. Let's do B. State the probability of not getting the infection if you are in the hospital. All right, so not infection. In hospital. Okay, so let's see what that is. Well, that would be, all right, I take my all cases, 100%, take away 35%, right? And that's going to give me 65%. So my answer is 65%. Just to explain this a bit more, this is not infection, or pardon me, this is infection, not hospital. This is the info they gave us, right? They gave us infection. Okay, the probability of getting a certain infection. So this is infection in hospital. So they wanted the complement again. They wanted not infection hospital. So that would be 65%. Those are known as the complements, right? You either have the infection or you don't. You either have the infection or you don't. The two parts make up a whole. You either have the infection or you don't. The two parts make up the whole. These were different groups, right? These were people that were not in the hospital. These were people that were in the hospital. All right, let's part C. Eric concludes he's safer if he does not go to the hospital. Explain the flaw in his reasoning. Well, if Eric has a serious health concern, he should consult medical profession, medical people to determine treatment. Okay, just saying you're never going to go to the hospital again is silly, right? That's not the way to live. Hi, Cynthia. I sent you an email a little earlier, so let me know how that goes. All right, I'm going to stop here now, and I'm going to do what I did because I really want to encourage people to try doing this a few on your own with me, guided help. So I'm going to stop for a moment, and I'm going to get you to work on assignment 2. So this is my little note to you. I'm just going to move up, and I'm going to say, work on assignment 2. I'll go over the questions 2 or 3 at a time every 10 minutes, okay? So same as I did before, I want to encourage you to do a little bit of work on your own. Okay, let's keep going on assignment 2, the big long assignment on probability. Number 7 is 300 people ride their bike to work one morning. Of these people, 225 are women. If a randomly selected bike rider is chosen, determine the probability it's a man. So this is again the complement, right? If we know that 225 are women, well, let's figure out how many are men. So 300 take away 225. That's going to give us 75. So this is the total number. This is the number of women. This is the number of men. Therefore, the probability it's a man, if someone's randomly chosen, is 75 out of 300. Okay. Number 8. 8A. A bag contains 5 red and 2 white. Bag and pick one. State the equals. All right, how many reds are there? 5. Okay, and how many marbles in total? 7, right? So I'll just label this one. Again, I'm not going to label all of them. This is the number of red marbles. This is the total number of marbles. Right. Now part B, what's the probability of pick white? All right, so probability of white, I don't think I have to do anything special with a calculator. If there's 5 red and there's only red and white, then that's going to be 2 out of 7, right? The probability you'll pick red or white, well, considering they're all either red or white, if I add up the red and add up the white, I'm going to get 7 out of 7. All right, now you can leave your answer as 7 out of 7, or you can just reduce that to 1 if you want to. Either answer is acceptable. All right, part D. State the probability you'll pick a blue marble. Well, considering there are no blue marbles, you have a 0 chance or 0 probability. So 0 out of 7, which is 0. Number 9. A bag contains 3 red and 5 black. 1 ball is selected. State the probability it's red. Okay, well, that's probability of red equals. All right, the number of red is 3. The total number of balls, 3 plus 5 is 8. Okay. State the probability it's blue. Well, that's the same question we had up here, right? Probability of blue. There are 0 blue out of the 8. So my answer is 0 out of 8, or just 0. So hopefully this is you're getting a little more comfortable with the symbology too, like the putting your capital B and then in brackets whatever you're searching for. Finally, number 10, a 6-sided die is rolled. So that's your typical die that you have in kids' sports games. So again, this is what it looks like. Often the game is played with 1 or 2 die. 2 die is a pair of dice. And each side has a different number of dots on it, ranging from 1 dot all the way up to 6 dots. So state the probability that a 4 is rolled. So probability you roll the side with 4 dots. There's only 1 side with 4 dots and 6 sides total. So I'll label this one because it's a new type of. So this is the total number of sides. And this is the number of sides with 4 dots. Okay, there's only 1 side with 4 dots, 6 sides in total. Part B, state the probability that an odd number is rolled. All right, so remember what the odd numbers are? The odd numbers are odd numbers on the die. Okay, well, that would be the one with 1 dot or 3 or 5. Okay, so 1, 3, or 5. So probability that it's an odd number equals, there's 3 of them, so 3 out of 6. Now, you could reduce this to a half, or you could call that 50%. Right? And how about part C? State the probability that we have a number less than 3. So probability less than 3, that's the less than symbol. All right, well, what numbers would those be? That would be less than 3. That would be the numbers 1 or 2. There's only 2 numbers less than 3, so that's 2 out of 6. And finally, part D, state the probability that a number greater than 4 is not rolled. That's a silly question, I think. It's a hard one to do. Probability that a number greater than 4 is not rolled. So basically, we're saying the probability that the number, probability that a 5 or 6 is not rolled. That's really hard to think about, right? So what would that be? If 5 or 6 is not rolled, that means I have to do the numbers possible would be a 1, a 2, a 3, or a 4, right? That leaves those numbers. So I guess my answer is there's 4 out of 6 numbers that a number greater than 5 is not rolled. To me, that's a really silly way to ask the question. It's very convoluted, I think we say. But that's the question they gave us, so we'll just leave it like that. So those are the next set of questions. I'm going to leave you working again. There's a lot of repetition in this exercise, but repetition does lead to being efficient, right, with the question. So I'm going to leave you with how about the next page? Okay, I'm leaving you with this next page from 11 to number 15. So I'm going to write that down. I'm just going to write that down. Work on numbers 11 to 15 on page 10 for the next few minutes. All right, I'll leave these answers up. And I'm just going to also, I'll leave this little note up too. Here. Trying to be efficient with my instructions. So I think you can see this. I'm just going to put that there. Okay, and I'll just leave the last few questions up. Okay, so take a few minutes and keep working. Okay, let's keep going. I left you off at number 10, and then I was leaving. There's still a lot to do, right? What I think, I'll just do as much as I can until the end of class, and then I'll post the rest of the answers online with solutions. So I'll start with number 11. Number 11, the following table indicates the principal cause of accidental deaths in Canada. That's kind of gruesome. State the probability that the accident died as a result of falls. Okay, so the probability, death from falls, right? Death from falling. So I have to look at how many people died in a fall and how many people died in total. That total number is always important, right? Sometimes they're nice and they provide it for us. Other times we have to do the totaling on our own. So there we go. How about burns? Probability death from burns. Um, 200 out of 4,200. And then finally, C, probability of mauling by a shark. Okay, that was kind of a silly one put in there. And you can see there's no category, there's no cause of being mauled by a unicorn shark. So that would be 0 out of 4,200. All right, let's do another marble question. Number 12. Again, we've got, I don't know if I have to do this one really. So probability of red, we've done so many of these already. So how many reds do I have? 3. And how many do I have in total? 3 and 4 is 7 and 5 is 12. Okay. So probability of blue. I've got 4 out of 12. Probability of red or blue. That means I add up the reds and blues. Together, 3 and 4 is 7 out of 12. And finally, part D, not blue. So the probability being not blue, well, this would mean if it's not blue, it's red and white, right? So there's 8 out of 12 are not blue. Okay. So these are fairly straightforward, I think. Number 13. If the 26 letters of the English alphabet are contained in a jar, state the probability that a selected letter is a J. Probability of a J, well, there's only one of them, right? One out of the 26. An A, B, or C. Probability of A, B, or C. Well, there's 3 letters that are possibles out of the 26. A vowel. It says in the instructions, Y is not considered a vowel. So the vowels are, just so you know, A, E, I, O, and U. So that's 5 of them. 5 out of 26. And then finally a consonant. Well, all the others are consonant, right? All other letters are consonants if they are not vowels. So there are either vowels or consonants. These two are complements of each other. Together they make up the whole alphabet. So the probability of it being a consonant is, if there's 5 vowels, that means there's 21 other letters left over. Okay. Number 14, A. A driver's school boasts that students who graduate from their program have a 90% chance of passing on the first try. Write 90% as a fraction. So 90% as a fraction is anytime you're given a number with a percent sign, it's kind of easy to put it into an automatic fraction because we just take the percent number and record it as a number out of 100. If the school has 50 students graduate, how many would you expect to pass? Well, they're asking me to find 90% of 50. Now, we've done this skill quite a few times before in this class. I automatically convert this to a decimal number, and I can do that by 90 divided by 100, or just know in my head that that's 0.90. Of means multiply. So 90% of 50 is going to give me 45, right? So I know that 45 students should pass the course. 45 students should pass. Should pass the driving test, I should say. Okay. State the probability of choosing a vowel from the letters in the word utopia. Okay, so let's see. How many vowels are in utopia? Well, if it's not a vowel, it's a consonant. So the vowels are U, O, I, and A. And let's see, how many letters are there in total? 1, 2, 3, 4, 5, 6. 6 letters in total. And 1, 2, 3, 4, 4 vowels. So basically the probability, if I do this in proper math language, the probability of selecting a vowel is going to be 4 out of 6. That's it. Okay, we've got a few more minutes left. I'm going to get you on for the rest of the class. I'm going to get you to finish up 16 to 20, and I'm not going to have time to go over these in class today. So I'm going to get you to, do 16 to 20. There's lots of repetition here, so that shouldn't be that difficult. If you have any problems on any specific one of the questions, let me know. Otherwise, I'm going to start the third lesson tomorrow. And I'll do all these by hand, and I'll make notes of them, and then I'll post those answers on the blog for you, though, so you have all the answers. Okay, so that'll be it for streaming today. If you have any questions, let me know. And I will be in touch with you tomorrow.